Hey, so this is gonna be a little vibing code session. Vibing is mandatory, coding is optional, but if you want to code with me, go ahead and do it, have fun, or do something else. Laundry, dishes. I can see all those dishes in your sink. Yeah. Fill up the dishwasher, get it done. You know, I definitely would never have a bunch of dishes piled up in my sink, so don't look at that. Anyway, so I know I've been gone for a while, and I don't know. That's just how I make YouTube videos, I guess now. But oh yeah, also apologies for not doing the Target crochet kit video. But here's the review. Don't buy it. It sucks. Anyway, so this is just gonna be a little coding vlog. Lately, I've been learning how to make emulators. I've been doing this tutorial from this website called Emulator 101, which is unfortunately down, but I was able to find the archive on the Wayback Machine, so I've been going through that. And only issue is written in C, and I'm not that good at C, so I am doing it in Swift. Yeah, besides that, not really much to get into except for the coding vlog. So thank you for watching. Remember to like and subscribe. I've been saying it at the end, but I'm gonna say it at the beginning because I want more subscribers, and I'm gonna try to be consistent. I apologize. Anyway, thanks for watching. Okay, so gonna record this on my Mac. I am also gonna throw on a little silly playlist for the vibes, so enjoy that. And first of all, I'm just gonna explain what I've done so far in the emulator, and then from there I am going to start coding. So let's go. All right, let me switch my keyboard over to my Mac and start screen recording. FD screen record key. Already got a typo. Okay, so we are recording. Cool. So, as you can see, I have a very big switch statement. I'm gonna adjust actually my little situation going on here. Goddamn. Camera. Sound go here. And then microphone over here. I don't think I have a camera. All right, hello. Got my coffee. Editor, cut to the B-roll of me getting coffee. I'm the editor. So anyway, yeah. So right here, I'm building in an Xcode. It's just a Swift package. Am I too far from my microphone? I should have planned this out better before I start recording, but you know me. You know, you might not, but if you do know me, you know that I'm not a planner. Okay. Microphone can go right here. Hopefully you can hear me okay. God damn. I'm gonna edit all this bullshit out. All right, anyway, or maybe I won't, because I'm lazy. I hate editing. Anyway, all right. So we got a big switch statement. Actually, first, let's look at the shell of the emulator. So to run the emulator, I'm running it on the command line using Swift argument parser, which is just a library that parses arguments for a Swift command line tool. To create this, I just ran Swift package new something. What the heck did I? Swift package init type executable. let's actually make this bigger. Yeah. And clear my screen. No. Clear my screen. Yeah. So yeah, Swift package in it. Give it a name. Give it a type. Is just say executable. Not clear at the end. I love this song so much. I'll put the playlist in the description if you want to vibe whimsically with me. Yeah, so that's how you create the package. It just creates an executable package. Only library I'm pulling in is so far is just the Swift argument parser for, as I said, parsing arguments. So only argument is just an input, which is a string, and that is the path to the file. Create a URL with that that path. Get the data. That file will be the ROM for Space Invaders. So it'll just be a bunch of bytes. So all data is an array of bytes. So turn that URL into bytes, set the program counter to 0, and then we are running a disassembler here. I have not started running the actual emulator yet. So if I run this, I don't think it'll work because I don't think I put the file in here. No, I did not. Okay, let's actually add a new folder with the file. I'm gonna call it files with the capital F, and then add files. I actually created a new project because I messed stuff up. So I'm doing another one. Okay, cool. So we have this here. I'm guessing it, yeah, just missing input. So we're gonna edit the scheme for running and pass the argument. Print the working directory. If you're doing this, if you're following along in Xcode, which I don't think you are, but if you were, when you put arguments on the command line like this for a path, I would do the full path, not like a relative path, because Xcode is stupid. All right, so pass in that. So we're running again. Cool. So this looks like probably nothing, but I will explain what's going on here. So all it's doing is running the disassembler, which loops through the data, and then for each byte, it will print out based on what the instruction is. So if the instruction is 0x00, it'll print no op. If it's 0x01, it'll print LXIB, and then print out the next 2 bytes, and then it will increase the length of the bytes. That tells it to increase the program counter, which is PC. Blah, 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 blah. It is, this is not the interesting part. This is just for debugging purposes. So, and also, I have not implemented the majority of the instructions in the disassembler, and I might not, because I don't care. Anyway, so this is where the actual emulator is happening. Like I said, I'm not really using it yet because I haven't really gotten to that. I've just been creating instructions. And I had one test for testing a certain instruction that I wasn't sure about if I was doing it right. But basically, so for an emulator, for this specific emulator, there are 1, 2, 3, 4, 5, 6, 7 registers, and each one of those contain a 8-bit unsigned integer or a byte. And then we also have condition codes, which basically tell the emulator what happened. So like Z is for 0, S is for sign, whether it's positive or negative. P is for parity, meaning whether it's even or odd. Carry or CY is carry for if there's a carry or a borrow for adding and subtraction. AC is auxiliary carry, which is not used by Space Invader, so I'm not implementing it. The tutorial is not implementing it, so which means I'm not either. And then pad, I don't remember what pad means. Yeah, and then as far as the state, we have the 6 registers. We have a stack pointer and a program counter. We have the memory, which is data, and then we have a reference to the condition codes up here, and then int enable. I don't remember what that is either, but we're gonna find out because we're reading stuff, and we're gonna figure it out together, I think. So there's just a class for the emulator here, and it just has a reference to the state struct, unit, pass in the state, and then run this emulate 8080p function, and that can throw an error if an opcode is not implemented. So we get the opcode from the memory, and we just find where PC is. Honestly, should probably just make the stack pointer a regular int, so I'm not doing these casts. So because it's a UN16, I was trying to copy the tutorial, which had it as a 16-bit integer, but honestly, I feel like it'd be better if it was just an int, so I'm not casting it to an int every time I need to use get from something from memory. I did not realize this before. Anyway, I'm gonna probably do that off camera if I change that to an int. But yeah, the program counter is just, it tells you where in memory you are, and the stack pointer is where you are on the stack. I imagine a lot of this could be a little bit confusing if you're not like not super familiar with how CPUs work, and I'm not either, so don't feel bad. This is why I'm doing it, because I'm learning. Let's see. So I wanted to check if OBS was still recording just in case. Actually, I should put that on the screen, so I am not surprised if it stops recording and then I just yap and there's no recording. So to emulate the CPU, we honestly just have a big ass switch statement, and each case is handling a different opcode. So the first opcode is just a no op, so all we're doing is breaking. Second one is, let's skip that because I don't remember what it is. Fourth one is just incrementing the B register. So all we're doing is creating an answer. Honestly, I think I did this wrong. Oh wait, no I didn't, because there's no carry. Okay, so all this is doing is adding 1 to B, and then it's setting the flags accordingly. This is not the best example actually for setting the flags and stuff. So let's actually look at 41. No. Let's look at 80. So this is adding register A to register B. So all we're doing is calling this add function I created, just a helper function and then passing in the register I want to add to A. So if we go to the implementation of that, we see we set the answer to A plus B, and we're casting each one to a 16-bit integer. That way, if there is a carry and an overflow over an 8-bit integer, we don't have to worry about that. And then we can just check whether the answer is higher than 255. That's what 0xFF means. If it's higher than 255, then we set the carry register to true, or the carry flag to true. And then this one, we're checking if it's negative, or if it's equal to, or if it's not equal to 0. So yeah, and then here we're checking if it's equal to 0. And then here we're checking if it's even or odd. And here we're setting the answer to the A register and casting it back to a uint8. Honestly, like, I've already done the arithmetic functions, the arithmetic group opcodes, so that's why I'm kind of glossing over this. But they're very similar. There's sub, there's add immediate, which is just adding the next the next instruction in memory. I can't talk. Yeah, and then we have adding with the carry. So in here, if there is a carry, we're adding 1 to it. Blah blah blah. All right. Anyway. I think I'm doing this wrong, maybe. Yeah. It's good that I'm videotaping myself as I'm realizing how stupid I am. So maybe my dumbness can be avoided in the future. Anyway, so yeah, I don't think I'm handling the carry flag right, but we'll figure that out later. Well, yeah, let me look at the book. Okay, I am back, and pretty sure I did the carry bit right. I just was a little confused. So ignore everything that just happened. Alright, so start recording my screen again. Alright, we're back. So I have completed the arithmetic, and I've completed about half of the branching group. So that would be just jumps, calls, and returns. So just moving through memory. Yeah, jump was fairly easy. Call is also easy. Jump, you literally just move the program counter. And for call, you do the same thing, except that you have to store the position. That way when return is called, you move back to where you started. Quite self-explanatory. My hair is doing a weird thing. I don't know what to do here. I don't know why I care. I just let it go. Just let it go. Yeah, it's not gonna be fixed. Also, it's hard to do this using camera because it's reversed. reverse. Okay. So I've actually implemented a few of the call ones. The only thing I have to do is each instruction has a regular version that happens all the time. So there's regular jump that will always jump no matter what. And then there's conditional jumps. So like a jump will happen only if the 0 flag is set. And the sign 1 is set and blah, 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 blah. And so I already implemented all of the jump instructions and the 0 ones for call and return. So I believe I need to do carry, parity, and sign. So we got a big list of all the instructions on my iPad here. Can you see that? No, you cannot. What if I cover my face? Nope, can't see it, but you're gonna have to take my word for it. There is a big list of instructions, and I am just going one by one implementing each one, and that's how you create an emulator. It sounds a lot more complicated. I mean, it seemed a lot more complicated than it was before I started learning this, but it's actually not that complicated. So we're gonna do. This website is it's not the best when it comes to finding what you need, because it's like on a different page. All the instruction codes are on a different page than the actual tutorial, so I'm constantly going back and forth, looking at which is which. Also, did you catch my sonic chain? Did you get that? I feel like it hasn't been in the shot, so I need to stand up straighter so it can be seen, or maybe raise up my chair. All right, cool. Sonic is there, and we're gonna go fast. No, we're not. We're gonna go very slow because I don't 100% know what I'm doing. All right. Let us see. I'm looking for. Darn it. I'm sure this is really interesting watching me stare down at my iPad. Okay. Yeah, I'm looking for. Okay. Call. No carry, and call carry, and then return no carry, and return carry. Okay. So each one has an abbreviation. So like call no carry is like CNC, call carry CC. So you gotta just go through this stupid list that I'm gonna link at the bottom. And just implementing each one. Okay, so call no carry is 0xd4. Each one of these are hex numbers, in case you were wondering. Okay. Oh, we're actually coded now. All right, so if this AI shit is actually kind of smart sometimes, because it kind of knew what I was gonna type, which is nice. I still hate AI. I do hate it, but this is nice. Okay, now we're looking for a CC. That's 0xDC. I know that some of them are capitalized and some aren't. I decided I didn't want to capitalize anymore. Oh, look, it's wrong this time. Wait, no, it's right now. Okay, whatever. All right, 0x. Wow, Apple, thank you for the robots that code for me. I really appreciate it. Let's see. Oh yeah, so I'm looking for RNC. RNC, brother. I'm a Republican. I actually went to the RNC. I met my hero, Hulk Hogan, and my other hero, Donald Trump, who is also Hulk Hogan's hero. Just kidding. Anyway, so, all right, RNC is 0xd0. Okay. So go right here. Case 0xd0. Boom. If not state blah 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 blah. Cool. Okay, now I'm looking for RC. No, I didn't want to do that. Looking for RC. Damn it. Alright, looking for RC in the list 0xd8. So that will be right here. Case 0x. What did I just say? D8? Yeah, D8. No, that's right. Alright, D8. If state, blah, 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 blah. It knows. It knows. The robots are getting smarter. Hopefully they won't kill us. Let's see. Okay, next. We are going to... sorry, I need to pull up the instructions again. All right, so, okay, CPO for, okay, parity. All right. Is, okay, first one, 0xe4 is if parity odd. Okay, what was that? I can't, why does my brain like lose what I'm thinking so quickly? It's because I'm old. All right, yeah, CPO. 0xe4. All right, cool. Case 0xe4. Yeah, I think it's not. If it's not parity, so because okay, so the reason is this one is not because this is parity odd. So parity is set if the parity flag is set if the number is even, I believe. Let me double check. Yeah, okay, yes. Yeah, it is set if the number is even. So for parity odd, we want to check if it's not set. And then for was that CPO? Yeah. And then for CPE, that would be called parity even, 0xEC. XEC, parity, blah, 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 robots, thank you. And now we will do return parity odd. That is 0x easy. Okay. This seems very tedious, probably. And I won't lie to you, it is. But I'm also having fun, so it's okay. It's tedious. If it was tedious and not fun, and I wasn't learning, then I wouldn't do it. I would probably, I don't know, be knitting or something. That was E8. Boom, 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 boom. Boom, 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 boom. We're Costco guys. Of course we code an emulator in our free time. All right, so, all right, done with that. Now we're gonna do sign. Okay. Sign is, I already forgot what the abbrev is. That is CP. I did not say that, YouTube. It's not the CP you're thinking, YouTube. It's CP for carry, no, what was it? Carry positive. It stands for carry positive. as in the number is positive, not the other CP. Not allowed on here. This ain't the dark web, and this ain't I don't know someone who got in trouble for CP off the top of my head, but I know there's a lot of YouTubers that have, and y'all need to get help. Anyway, so see, I'm gonna stop saying that. Okay, 0x F4. Okay, so positive is sign is not set, I believe. Because yeah, if the sign is set, that means there's a negative. There's a negative sign in the sign bit, and that means that it is negative. The number is negative. Okay, so all right, we're gonna do that. We got that one done, and then where's RP? Okay, 0x F0. So let me write about this. I believe no, it's a little bit. It's about this. 0. Turn, boom. And then what are the other ones? I forget. CMRM. Okay. Where's CM? 0x FC. I'll be above this. That, and then yeah, return for minus is F8. I'm glad that it knows. I'm gonna, I think I'm gonna switch up the music. Be right back. I didn't even realize the playlist had changed. Alright, let's do this. Rally House to get low poly to. That's the name of the playlist. I hope this isn't copyrighted. If it is, fuck it. This video's not coming out. Anyway, it's not like I'm monetized anyway. I don't care. Let's see. Cool, that was actually all of the branch group, I believe. So, wait, no, it's not. All right, I have two more. PCHL, which doesn't. We'll do an unconditional jump to the address in the HL register pair. Okay, so H and L tend to be used as a register pair. That allows for 8-bit systems to operate on 16-bit numbers by putting two registers together. So we will, I keep accidentally typing things. All right, so let's check that. Where is that? I have no idea how long this video is. Let's see. So we got TCHL. This is kind of vibey. The music, that is. Hey, here we go. All right, 0xE9 is 4. I could just say 9 probably. Because 0x there every time. And it's not part of the number. Yeah, the 0x is just to denote that this is a hex number. It tells the compiler that the number is hex. All right. Anyway, so I'm just gonna. Yeah, I'm gonna actually copy this. But gonna change it because it's not actually what we wanted. All right, how do I do this? All right, we're gonna set the program counter to a oh. I think I state H. And L. I believe that's all I really have to do here. Let me see. Yeah. Okay, cool. Okay, so all we're doing is we're taking the value in register H, shifting it over 8 bits, and then ORing it with register L, and that will create a 16-bit integer that we can set in the program counter. Looking back at some of this other stuff, I do believe I actually need to change something though, because yeah, okay, I'm noticing an issue that I did here. Yeah, so for the places where I'm using the H and L, I'm actually setting it in a uint 8 after shifting the bits over, which is incorrect, because when I shift them over, they're gonna overflow. So this will probably crash. So I actually need to 16. Honestly, I think I need to actually create a helper function, so I'm not copy and pasting this over and over. But yeah, just call it HL and then turn uint 16. And then this. That's correct. Okay, so I'm gonna copy this and do a little replace. This one. And then the thing I was just working on, I think I may have just messed it up with that find and replace, but it's easy to fix. Oh, I didn't mess it up. But I don't need this cast anymore. Okay, cool. Yeah, so we're gonna set HL to the PC, the program counter. Okay, cool. That that is done. Yeah, if I'm doing stuff wrong, it's because I'm not smart and I'm new to this. So keep your comments to your damn self. Just kidding. If I do something wrong, let me know in the comments. Let's see, branch group. That's where I was. Okay, lastly, RST. This group. It pushes the return address on the stack, then jumps to a predetermined low memory address. Okay. All right, let's find that in the list. RST. Okay. That'd be the last instruction. Just put this in helper. I don't need a helper because it's probably not that long. So we're gonna all right, so it's just gonna set okay, so there's a bunch of different ones of these RSTs. So I'm gonna start actually here. RST1. I'm gonna read there's a data book that explains the thing, the processor. So I'm gonna be forced to read because I don't know what this is supposed to do. Yeah, here we go. All right. The higher order 8 bits of the next instruction address are moved to the memory location whose address is one less than content of the register stack pointer. The low order 8 bits of the next instruction address are moved to the memory location whose address is 2 less than the content of register stack pointer. The content of register stack pointer is decremented by 2. Control is transferred to the instruction whose address is 8 times the content of NNN. That made no sense to me. Okay, let's think about this. Okay, so RST stands for restart. So, okay. So what we're doing is, setting the stack pointer. So yeah, I'm gonna copy and paste this because that's gonna be the same. Then, and then reduce the stack pointer by 2. It's gonna be the same as that. And then 8 times NNN. What the fuck is NNN? These abbreves are difficult. The abbreves are diff. And they're very confusing. Oh, I'm tired. All right. Just notice the sun's out. I can turn off my lights. That sunshine and fresh air got me feeling normal. Good morning. Let's see. Control is transferred to instruction whose addresses 8 times the content. Hi? I don't know what the fuck that means. Sorry, my mom's texting me. Okay, so alright, I think probably after I finish this, I might call this video done for now. Call $8. What the fuck is $8? Alright, I'm gonna Google this actually. That's probably a smart thing to do. So I've been able to find like articles on Tutorial Point for these instructions, but they're for the 8085, not the 8080. So I'm hoping that they're the same, but like that's what I've been using to figure this shit out. Oh, there's an RST0. Starts at 0. Okay. Oh, I see. So it you multiply 4 by the. Okay. So I do want to put this in a function though, because this is gonna be multiple thingies. All right. So we're just gonna call that RST, and then we're gonna pass in. I think that's all I have to do, but okay. I think I got it, but I also could be wrong because again, I'm not smart. Okay, so I don't know. This could be wrong, could be right. But yeah, we're gonna just implement these for now from what I think is right, and then in the next video maybe I will figure out that I was right or figure out that I was wrong. But no need to just have y'all on here, but the robots seem to know what I'm doing, so it kind of leads me to believe that I might be right. You know, I don't know. All right, we're gonna say okay. So, what is the next one? If the robot guesses, it did guess. It guessed the right one. No, that's wrong though. It's supposed to be 10. It's close. Alright. D7, and the next one is the F. You're so close. Wait, is it? Yeah, it's right. 18. I don't know if I'm doing these in order anymore, but I don't really care because I kind of like having all these in the same place instead of the same thing. Yeah, I guess they don't have to be in order necessarily. I also could probably do like some comments that say what instruction I'm implementing, but again, lazy. Robot is right there. I want to hear comments about saying that I'm not doing anything, because I had to think this through. Just because the computer knows what I'm about to type doesn't mean that I didn't know too. And I have to confirm it. I have to be like, you're right, computer. So don't be like, the computer's coding it for you. No, I'm coding it. The computer's just my assistant. It should be. I pay a lot of money for this computer. All right. Anyway. All right. We got to do 6 and 7. Okay. 6 is F7. RST. 30. And then last one is FF. Is RST 38. Cool. All right. We're done. All right. I'm going to stop screen sharing. All right. So this has been a little code and vibe sesh. Thank you for watching. Don't forget to like and subscribe. And I am going to try my rootin' tootin'est to be consistent on YouTube. I will be back with more computers, more crochet, more knitting, more all of that bullshit that I love and you should love too. Anyway, thank you for watching. I'm Maddie. Like and subscribe. I'm gonna say it again. I'll say it one more time. Like and subscribe. Thank you. Thank you so much for watching. Okay, bye.